Let us start with Module 6, Introduction to Communication Systems. Moving on to the first lecture of Module 6. In this entire module, we have to study evolution of communication systems, radio communication and mobile communication. So in this lecture 1, we will be discussing about a basic communication system, mobile generation technologies and introduction to modulation. A basic communication system. So what do you mean by communication? Communication is the process of exchange of information between 2 points, and the electronic system which is used for this information exchange is known as a communication system. That is, an electronic system which is used for conveying an information from a source to a destination is known as an electronic communication system. So this is the block diagram of a basic communication system. Any communication system will have these 3 parts: the transmitter, the receiver and the channel or medium. Now let us see what are the functions of each of these parts in detail. So first one is the transmitter. So we have already said that communication is the process of sending information from a source to a destination. So sometimes the signal or the information from the source may not be in a form which is suitable for transmitting through this channel. So in that cases, the information signal has to be converted to a form which is suitable for transmitting through the channel. This function is performed by the transmitter. So the transmitter makes the signal or the information from the source suitable for transmission through the channel. So next one is the receiver. As the name indicates, the receiver receives the transmitted signal and it converts the transmitted signal into a form which is suitable for the destination, or the transmitter have already converted the information signal into a form which is suitable for the channel. Now the receiver has the function to convert the signal back into the original form so that the destination can understand properly the signal. So the next part is the channel, also known as the medium. So it is a path for transporting the signal between the transmitter and the receiver. So channel acts as a physical medium which connects the transmitter and the receiver. So example of channel are cables, wires or air, etc. So it connects the transmitter and the receiver, or it carries the information from the transmitter to the receiver. So let me say, for example, assume a person is talking directly with another person. So in that case, the person who speaks is the transmitter and the information signal, the speech of the person, travels through the air in between them in the form of sound waves. So here air acts as the channel or medium and the person who listens to it acts as the receiver. So when the distance between the speaker and the listener are very high, we have to change the type of communication and the channel used. So next is the classification of communication systems. Communication systems can be classified in many ways. So you have heard of radio communication, television, mobile communication, etc. This classification is based on the technology used for communication. So based on the technology used, communication systems can be classified as radio communication, mobile communication, television, telegraph, computer, like that. So we have to focus on to the classification of communication system based on the channel used, that is based on the medium or channel used for communication. Communication systems can be classified into two types. They are line communication and radio communication. So line communication. Line communication is also known as wired communication. So in this, the medium of communication is a pair of conductors. That is, the transmitter and receiver are connected by means of conductors. The conductors can be wires, cables, optical fiber cables, etc. So have you heard of power line communication? Power line communication is nothing but the sending of information signal through our overhead transmission lines, that is the line carrying AC power. So that is known as power line communication. The message signals are sent along with AC power through overhead transmission lines. So power line communication also comes under this category, line communication. So here the transmitter and receiver will be connected by conductors, which can be cables, optical fiber cables, etc. So next is radio communication, which is also known as wireless communication. So this line communication suffers from a lot of disadvantages. The main disadvantage is the lack of mobility. That means we cannot freely move our devices, which is physically limited by the length of the line connecting between the transmitter and the receiver. So as there is a line which is connected between the transmitter and the receiver, we cannot freely move our devices. And another problem is that the cost of installing or reconfiguring the cables is very high, and also the cables are prone to damages. So in order to overcome all the disadvantages of line communication, the radio communication is introduced. So it is a wireless communication technology, and here the signals are transmitted through open space or air as electromagnetic or radio waves. That is radio communication. So it can overcome all the disadvantages of line communication. So next I am going to a topic, evolution of mobile generation technology. So before this topic, there is another topic given in your notes. That is evolution of communication system. Evolution of communication systems is already given in your notes that I have shared with you. So just go through it. So it is a tabular format, and in that the year by year developments happened in the communication systems is given. You just go through it. You need not by heart the years, just understand what are the advancements that happened one after the other. So just go through it and try to memorize the advancement that have happened one by one. So now moving on to evolution of mobile generation technology. So all of us are familiar about the various mobile generation technologies. We have heard of 2G, 3G, 4G mobile connections. This G is nothing but the abbreviation of generation. Starting from 1G, mobile generations have now reached up to 5G, the fifth generation. So let us see what are the features of each of the mobile generations. So the first generation, or 1G. It was launched in 1979 in Japan. It supports only voice calls, and it suffered from a lot of disadvantages like poor coverage, low sound quality, and lack of roaming support between operators. So these are the disadvantages of the first generation mobile technology. Poor coverage, low sound quality, and lack of roaming support between operators. So even though the first generation had such disadvantages, it was a very success. And this success has led to the development of the second generation. So remember, all these are given in your notes, but there are only a few points in your notes. So please listen to what I am saying and note down all these points. So now moving on to the second generation or 2G. So 2G was launched in 1991 in Finland, and it was launched under GSM standards. What is GSM? Global System for Mobile Communication. So the second generation used the GSM standards, Global System for Mobile Communication, and it used a digital technology. For the first generation, it was an analog technology used, but the second generation has advanced to a digital technology, and hence the voice calls were more clearer in the 2G mobile phones. So in addition to that, the 2G mobiles supported text messages, picture messages and MMS. So in first generation, there was only the provision for making voice calls, but the second generation supports text messages, picture messages and MMS. MMS is multimedia messaging system. That is, we can send photos in JPG or JPEG format using the 2G mobile technology. And regarding the data transfer speeds, the initial transfer speeds of 2G was up to 9.6 kbps. With the installation of new towers, the speed increased up to 40 kbps. And with the use of edge technology, the speed reached up to 500 kbps. എഡ്ജ് എന്ന് പറഞ്ഞാൽ ഒന്നുമില്ല, ഡേറ്റ ട്രാൻസ്ഫർ കേപ്പബിലിറ്റി ഇൻക്രീസ് ചെയ്യാൻ യൂസ് ചെയ്യുന്ന ഒരു ടെക്നോളജിയാണ്. സോ ആ ടെക്നോളജിയും കൂടെ യൂസ് ചെയ്തപ്പോൾ 2G ഹാസ് അറ്റൈൻഡ് എ സ്പീഡ് അപ് ടു 500 kbps. So next one is 3G. 3G was launched in 2001. It helped to access data from any location in the world. So this made international roaming services possible for the first time. So in 1G and 2G connections, roaming services were not possible. So 3G made the international roaming services possible for the first time. Its data transfer capabilities were 4 times more than that of 2G. So data transfer capabilities increased up to 4 times more than that of 2G. So this helps to support new services such as video conferencing, video streaming and Skype. So the theoretical data speeds of 3G was up to 7.2 Mbps. This is the theoretical data speed, 7.2 Mbps, but practically 3G had a data speed around 3 Mbps. And the launching of iPhone was during the time of 3G technology. It was in 2007. So next is the fourth generation mobile technology, abbreviated as 4G. 4G was launched in 2009 in Stockholm, the long-term evolution standard. So all of you know this term LTE. It is already written on the top of our mobile phones, LTE. So LTE means long-term evolution. So it is subjected to evolution. So the 4G mobile technology was launched as the long-term evolution standard, LTE standard. It made high-quality video streaming a reality for millions of consumers. It supported high-quality video streaming. And 4G offers fast mobile internet access with a speed up to 1 Gbps. So 4G can have speeds up to 1 Gbps theoretically even if we are not getting it. So with this high speed, it can support gaming services, high definition videos, high quality video conferencing, etc. The important thing is that the change from 2G to 3G requires only the switching of SIM cards. But for 4G, mobile devices need to be specifically designed. That is, നമ്മൾ 2G യൂസ് ചെയ്തുകൊണ്ടിരുന്നിട്ട് 3Gയിലേക്ക് മാറണമെങ്കിൽ നമ്മുടെ മൊബൈൽ ഫോണിൽ സിം കാർഡ് മാറ്റേണ്ട കാര്യമേ ഉള്ളായിരുന്നു. 2Gയിലെ സിം മാറ്റിയിട്ട് ഒരു 3G സിം ഇട്ടാൽ മാത്രം മതിയായിരുന്നു. അതാണ് പറഞ്ഞത്. സ്വിച്ചിങ് ഫ്രം 2G to 3G requires the switching of SIM cards only. പക്ഷേ 3G യൂസ് ചെയ്തുകൊണ്ടിരുന്ന ഒരു മൊബൈൽ ഫോണിൽ നമുക്ക് 4G യൂസ് ചെയ്യാൻ പറ്റുമോ? ഇല്ല. So for using 4G, we need specifically designed mobile phones. അതാണ് പറഞ്ഞത്. Mobile devices needed to be specifically designed for 4G. So at that time, the mobile manufacturers started producing or manufacturing 4G ready handsets and their profits dramatically rised. So all of us needed to change our phones in order to use 4G. So at that time, the profit of mobile manufacturers increased dramatically. So now 4G is the current standard around the globe. Almost all the peoples are using 4G now. So next is the 5th generation mobile technology, 5G. 5G is a new global wireless standard after 1G, 2G, 3G and 4G networks. 5G enables a new kind of network which can connect everyone and everything together. That is, it can connect, the 5G mobile technology can connect everyone and everything together. That means it can connect machines, objects and devices. 5G wireless technology is meant to deliver very high data speeds and it is very responsive. Responsive means there is a very small delay between the command and response. That is, the network can respond rapidly. That is meant by responsive. So the 5G network is very responsive. It is more reliable, thus having very high data speeds, massive network capacity and increased availability. So the advantages of 5G technology are very responsive, more reliable, very high data speeds, increased network capacity and increased availability. And the 5G networks are said to have a data speed up to 10 Gbps. So the higher performance and improved efficiency empowers new user experiences and it can connect new industries. So next topic is the modulation. So we have already studied what communication is. So communication is the sending of information from a source to a destination. In communication, information signals has to be transmitted over long distances. The information signals are usually low frequency signals. So they can be transmitted through cables or optical fibers. As they are low frequency signals, they can be transmitted through cables or optical fiber cables. But they cannot be directly transmitted through the space or air. For this, that is for transmitting through the air or for wireless transmission, it is required to increase the frequency of the signal. This can be done by a process known as modulation. So basically, modulation is the process of increasing the frequency of an information signal in order to make it suitable for transmitting through long distances. And modulation is actually defined as the process of varying one or more properties of a periodic waveform known as carrier wave in accordance with the instantaneous values of the modulating signal. So modulation is the process of varying one or more properties of a periodic waveform known as carrier wave in accordance with instantaneous value of the modulating signal. So from this definition, we can see two signals, the modulating signal and the carrier wave. The modulating signal is the low frequency information signal. Our information signal that has to be sent through the space is known as the modulating signal. It is having a low frequency, and carrier signal is the high frequency signal which carries the information through space in the form of radio waves. So our information signal is known as the modulating signal, and the high frequency periodic signal for carrying our modulating signal or information is known as the carrier wave. The device which is used to modulate the information signal using the carrier wave is known as the modulator. So, in order to transmit our low frequency information signal known as the modulating signal through space, we have to increase the frequency of the signal by using another signal known as carrier signal, which is a high frequency signal. So, the device which performs this function is known as the modulator, and the signal obtained after modulation is known as a modulated signal. So ഇവിടെ പറയുന്നത് നമുക്ക് സ്പേസിൽ കൂടി സെൻഡ് ചെയ്യേണ്ട നമ്മുടെ ഇൻഫോർമേഷൻ സിഗ്നൽ എന്ന് പറഞ്ഞാൽ ലോ ഫ്രീക്വൻസി സിഗ്നൽ ആയിരിക്കും. സോ അതിനെ നമുക്ക് ഡയറക്റ്റ് ആയിട്ട് സ്പേസിൽ കൂടി സെൻഡ് ചെയ്യാൻ പറ്റത്തില്ല. സോ സ്പേസിൽ കൂടെ ഡയറക്റ്റ് ട്രാൻസ്മിറ്റ് ചെയ്യണമെങ്കിൽ അതിൻ്റെ ഫ്രീക്വൻസി ഹൈ ആയിരിക്കണം. സോ നമ്മൾ മോഡുലേറ്റിംഗ് സിഗ്നൽ, നമ്മുടെ ഇൻഫർമേഷൻ സിഗ്നലിനെ ഒരു കാരിയർ സിഗ്നലുമായിട്ട് പ്രോസസ്സ് ചെയ്ത് ഹൈ ഫ്രീക്വൻസി സിഗ്നൽ ഉണ്ടാക്കും. കാരിയർ സിഗ്നൽ എന്ന് പറഞ്ഞ ഒരു ഹൈ ഫ്രീക്വൻസി സൈൻ വേവ് ആണ്. നമ്മൾ നമ്മുടെ ഇൻഫർമേഷൻ സിഗ്നലിൻ്റെ പ്രോപ്പർട്ടീസ് ബേസ് ചെയ്ത് ഈ കാരിയർ സിഗ്നലിനെ മോഡിഫൈ ചെയ്യും എന്നാണ് പറയുന്നത്. ഇൻ അക്കോർഡൻസ് വിത്ത് ഇൻസ്റ്റന്റേനിയസ് വാല്യൂ ഓഫ് ദ മോഡുലേറ്റിംഗ് സിഗ്നൽ, നമ്മുടെ ഇൻഫർമേഷൻ്റെ വാല്യൂ അനുസരിച്ച് കാരിയർ സിഗ്നലിനെ മോഡിഫൈ ചെയ്യും. അങ്ങനെ ആ മോഡിഫൈ ചെയ്ത കാരിയർ സിഗ്നലിനെ സ്പേസിൽ കൂടി സെൻഡ് ചെയ്യും. ആ സെൻഡ് ചെയ്യുന്ന സിഗ്നലിൻ്റെ പേരാണ് മോഡുലേറ്റഡ് സിഗ്നൽ. മോഡിഫൈഡ് കാരിയർ വേവ് ആണ് മോഡുലേറ്റഡ് സിഗ്നൽ. ഈ പ്രോസസ്സ് ചെയ്യുന്ന ഡിവൈസ് ആണ് മോഡുലേറ്റർ. So now the need for modulation. So this is an important topic. What are the needs for modulation? So first point is it reduces the height of the antenna. So modulation reduces the height of the antenna, and the minimum height required for an antenna is equal to lambda divided by 4, where lambda is the wavelength of the signal and lambda is equal to c divided by f, where c is the velocity of light and f is the frequency of the radio wave. So substituting lambda equal to c by f, we will get height of the antenna is equal to c divided by f into 4. That means when frequency increases, height of the antenna decreases. So by the process of modulation, we are actually increasing the frequency of a signal. So when the frequency increases, height of the antenna decreases according to this equation. So next is the modulation avoids mixing of signals. Our modulated signal which is sent through the space will not mix up with another signals. So next is it increases the range of communication. So we have already said this point. So we are doing this modulation for sending our information signal through long distances. So modulation increases range of communication. Range means the distance through which the communication signals are sent. So next, it allows adjustments in the bandwidth. Bandwidth is the frequency range of our signals. So modulation allows adjustments in the bandwidth. Next, it overcomes equipment limitations. And also it allows multiplexing of signals. Multiplexing means combining different signals. So it also allows multiplexing of signal. So try to by heart all these points 1, 2, 3, 4, 5 and 6 points. This is an important topic, so just by heart it.